Okay, a common question that I get asked is because the function of the actuator, especially on the fail-safe side, is largely dependent on our solenoid valve. And the solenoid valve is actually proprietary to the Easytork. The question I get is if they can use a third brand solenoid valve to get the fail-safe function with our actuator. And the answer is yes. How you do that is with our we call this the EPV, which is basically just a pilot valve. But before I get into details, I'll show you guys how this actually works and how to set it up. Like the solenoid valve, the components in the bag is all exactly the same. You got the two donuts and then you got the two O-rings. Again, the donut that's completely open, stick on the bottom, and this one with open hole in the middle, you stick over here. Got the two O-rings, they go over here and here. That's how it looks like in detail. Got two screws. Put this in. So what's going to happen with this is when I charge this with air, the actuator is going to open the valve, and when I lose the air to the actuator, it's going to drive the actuator to its fail position. Okay, here we go. So charging with air, with loss of air, goes into the fail close position. Again, charging it with the air, with loss of air. So in this type of setup, what most people do is they nipple mount a third-party solenoid valve, for example, an ASCO, to the setup over here. What I'm going to also demonstrate is how to make it from a fail close to fail open. And what you would do, loosen these two bolts. There's actually a grub screw over here, so I'm just going to get rid of it because it gets in the way of accidentally setting either the solenoid valve or the pilot valve in either open or closed position. So as you remember, I had this set up pointing this way. Now I'm just going to turn it upside down. Okay, now it's with air, it's staying in the closed position. With a loss of air, it's going to go into the open position. And just like the solenoid valve, just by turning the pilot valve or the solenoid valve upside down, you're going to get this type of function. So what we haven't talked about here today is how to mount this actuator to a wide variety of different valves with the flexibility of the drive insert, with the flexibility of the solenoid valve with the knob going in or out, makes it double acting or fail safe. Installing it pointing upside down or pointing up will make it from a fail closed to a fail open. The other thing that makes our actuator fairly easy is that all your standard limit switches will mount directly on top. So that's not really a big problem for us. In case you're wondering how the actuator looks like on the inside, that's how it looks like on the inside. It's got a little vane that goes left and right, and this is what actually connects to the valve stem that turns it into open or close. And instead of using springs, we have an onboard air reservoir as the fail-safe mechanism, which is why when I lose this air, it's driving it to the fail position, even though there's no air supply. It's using the air that's stored in the air reservoir to drive the actuator to its fail-safe. So by moving away from the springs, this actuator is actually much smaller than pretty much any actuator in the market, and it's also much lighter because you don't have to, this actuator is not having to fight against the spring. We can keep the size, we can keep the weight minimal. Empirically, on a 12-inch butterfly valve, a traditional rack and pinion will weigh about 120 pounds. This actuator, for the same amount of torque that the rack and pinion produces, weighs only 45 pounds. So you're looking at about almost a third to a half the weight of a traditional rack and pinion by using this type of design.